Hi, let's talk about test-driven development, or TDD for short. I'll talk about why test-driven development is not about testing. It is instead an iterative way to figure out the best solution design. I'll also talk about TDD on the level of acceptance tests, because all the examples out there are focusing on the unit test level, which didn't help me out a lot when I was learning TDD. I could solve for the smaller cases, the pure functions, the easy things to start with. But when I started to actually apply it in a React code base or acceptance tests, I wouldn't really know how to solve for these problems. I'll talk about the why of test-driven development. I'll talk about the TDD loop, which is the basic workflow description with an example in JavaScript. And I'll talk about TDD in an acceptance testing environment so that you can apply it with your product owner and your team to get the true value out of test-driven development. Let's get into it. So why test-driven development? TDD in principle is about writing the test before you write the code, the implementation. Now, why would you do this? This sounds very counterintuitive. There's a whole bunch of reasons for this. I'll talk about the practical reasons first. When you write the test first, you know when you are done. You have thought about what it means to be done. You have come up with a measure of being done. This means that you will have an easier time implementing. In addition, you can change code written in a TDD style more easily because you have test coverage exactly where it matters. When you are refactoring code that was written in a TDD style, if you start breaking things, which often happen during refactoring, you know exactly what is going on because the right test will fail, pointing you at where you need to fix either your test or your implementation. This is often something that costs you a lot of time if you don't have good test coverage, if you don't have tests at all, or if it wasn't written in a TDD style. It costs us developers a lot of time to figure out what exactly the problem is. In addition, code is always testable, obviously, and by definition, because you need to write your test first. You will always have tested code, unless you are breaking the pattern. But the advantage here is that this is something that is really difficult to get if you are not writing code in a TDD style. It's a common problem for code bases not written in TDD that half of it is testable, or code is very difficult to test because it doesn't have a style that makes testing easy and you need to mock half the world on objects and things that you need to inject. It is not easily testable code. Code written in TDD fashion does not have, or has at least a lot less of this problem. Now on to the bigger reasons. TDD allows you to write software components more robustly. It allows you to get to a higher code quality because you are focused on simplicity. Writing the test first makes sure you are focusing on only satisfying the test result. It prevents you, therefore, from starting to predict the future. It prevents you from optimizing for scenarios that might never happen. This is called Yagni. You ain't gonna need it. It also allows you to work in smaller steps, to build smaller pieces, one thing at a time, one small atomic commit at a time. Atomic commits is a version control best practice that many people find difficult to achieve. TDD helps you in achieving this because it focuses you on writing the test first. You know what to achieve and only that, and then you are done on to the next task. You can split up your tasks in smaller pieces more easily when using TDD, and therefore you have an easier time. It also yields code that is less coupled and therefore again more easy to change. Your code quality will increase because of this. If you have a higher cohesion, less coupling, I have a completely different video about this. You should probably check it out if you want to learn more about this. TDD is an easier way to achieve that end result that we all want. And finally, your tests will become your documentation. Living documentation even. It can never get out of date unless your tests are dead code or you're not fixing failing tests. They will always be the current state of the code base, which is highly valuable for transferring knowledge to colleagues, peers, or whomever you're working with together, even future you that has forgotten how this thing works right now. Robert Martin says writing tests after the code is a complete waste of time. You are only writing tests because you have to. You are satisfying some procedure that is making you to write tests. The suite of tests exists so that we can refactor, so that code doesn't rot, it doesn't become bad quality, so that we do not become afraid of our code, so we can easily change it all the time. Afraid of our code, you're thinking, but many people have this. if you look at code bases, there's always this one component that developers would rather not touch because it's called complex or technical debt, or it's this old thing, this legacy piece. Think about that. That is just a piece of code that wasn't touched for a long time, has bad coverage, and every time we touch it, something else unrelated somewhere breaks. This is not how code should work. This is simply because it wasn't written in a test-driven development style. Dave Farley uses the analogy of double entry bookkeeping used in accounting. It is about having a workflow that allows you to verify your work. In accounting, you have many layers of calculations piled on top of each other. And if you make a mistake, or if somebody else made a mistake, you have to figure it out. It is very difficult, it is very time-consuming and very frustrating to figure out where the mistake was made. And if you would have this double entry bookkeeping, or if you would have test-driven development, if we bring it back to software development, exactly the right thing, exactly the right test will fail. A red light will pop up somewhere pointing you in the right direction. This is where it's going wrong right now. This is what you need to fix. And you won't have to spend many an hour in the debugger or figuring out what is going on. You'll even see that the more you use test-driven development, the less you'll use the debugger. Some people, even Robert Martin, says, I don't use the debugger anymore because I do test-driven development. I also want to mention that test-driven development is a skill, something you can learn. If you don't know how to do it right now, that is okay. You can learn, you can practice, and at some point you will have the skill. You will know how to do this. This is opposed to a discipline or a school of thought, a church you have to join. That's not what's going on. This is simply a skill. Next, let's talk about the TDD loop, how you would do test-driven development. First, one small thing I want to talk about. If you don't have clear requirements for the software you're working on, TDD is possible, but it will require more effort from you as a programmer, because you will have to do part of the product owner's job as well. And if you think about this, this is really a good thing that we have a process that alerts to us, that halts us. Hey, you don't have the right things you need to start working, but you are being asked to start working. So it is good to take this step back, first set up better criteria for where you're going to work on, then start working on them. Your acceptance criteria will become almost literally your test cases. Robert Martin defines test-driven development as 3 laws. You are not allowed to write production code unless it is to make a failing unit test pass. Test first. You are not allowed to write any more of a unit test than is sufficient to fail. Compilation failures are failures. You are not allowed to write any more production code than is sufficient to pass the one failing unit test. This is really focused on unit level, and later in this video we'll also talk about acceptance test level, but it's still good to keep this in mind. In 3 words, test-driven development is fail, pass, refactor. Also called red-green-refactor. Red because your test is red, it is failing. Then green because it is green, is succeeding. The discipline is to first write a test, then run the test suite, so to make sure it is failing, then make the test pass. And only writing the code is necessary to make this test pass, no other code. Then refactor to code quality standards. The moment your test passes is the time to take a step back and think, is this the way I want to achieve this thing? Make sure you keep the test passing, and this test is then guarding you from making refactors that will turn the test red again because you are running the test in the meantime. Let's see what it looks like. So let's do a classic FizzBuzz kata to get a feel for what it looks like if you write the tests first. So we need to import this stuff, import FizzBuzz from /FizzBuzz, export const. It gets some input and gives some output. We have a test case now. So number in, string out. If you call FizzBuzz, we expect the result to equal, so say we throw in the number 42, we want it as a string out. Let's make sure the test fails. Indeed, it fails. Undefined returned. Let's implement it. return as string s. There we go. Let's implement the second case. For multiples of 3, return phys instead of the number. Multiples of 3, return phys. So now we have a test case that, let's take a number 9, which is a multiple of 3, and let's expect it to be phys. Of course, it isn't going to work yet, because right now our function doesn't do this. I'm going to add an if statement. If s is a multiple of 3, then we're going to return phys. So 42 apparently is also a multiple of 3. I guess so. So let's take the number 2 as a better test case. There we go. Next case, for multiples of 5, return buzz. So this is going to be a fairly similar case. Multiple of 5 can be 10, for example. And now that doesn't work, so we're going to add that case. Multiple of 5, return buzz. Yes, and for numbers that are multiples of both 3 and 5, phys buzz. Of 3 and 5. Phys buzz. So 15 is 1. Now that it fails, I can start implementing it. Phys buzz. There we go. That's all there is to it. Right now I will look at this function and I will ask myself the question, does this meet the quality standards that I like for a code base? For example, right now I am accepting an argument, but this could throw errors or nonce or whatever. If their type is not wrong, I may want to introduce typing, or I may want to always convert this to a number by calling number around this to make sure this will function all right. There's many ways of now improving the code quality. For this simple function, that isn't the case. Finally, let's talk about TDD on the acceptance test level. Many people have worked with TDD, especially if they're beginners, on a unit test level. They've done the physbuzz examples, they have the pure functions that were easily to write in a test-driven development way. But now they need to move on to larger things, entire user stories or even bigger ones. Let's get into the definition first. A definition according to the Agile Alliance is an acceptance test is a formal description of the behavior of a software product, generally expressed as an example or a usage scenario. This is a very useful definition for me. There are indeed lots of user stories written as examples, usage scenarios. I've presented one in my previous video as a user persona. I want feature so that I can get user value or business value. The moment your product owner writes your user stories in this way, your tests can focus on the what instead of the how, which again is a sort of interface thinking. Acceptance tests are also known as functional tests or end-to-end tests, API tests. They can be any of these, depending on what you are delivering. If you're an internal team, you're delivering an API, you are probably writing API tests as your final acceptance test. If you're focusing on UI development, maybe your end-to-end tests with Cypress if you're a front-end developer. The workflow is to first write a failing acceptance test and then a failing unit test, creating two different TDD loops nested inside of each other. Every time you create a failing acceptance test, you would need to write lots of code to be able to satisfy that test. So this is the moment you step into the nested loop. You go into the red-green-refactor TDD loop of unit level. You might implement many functions in an entire module which would have multiple loops there. This is fine. The moment you have satisfied the outer acceptance test, then you can decide to refactor some more and write another acceptance test. So what defines the outer acceptance test? This is, as much as possible, together with your product owner, preferably a sub-feature of what you're trying to build. If you look at the user story, maybe it's a very small one and you have just 1 or 2 acceptance tests for this. Maybe it's a lot if it's a very big feature. Maybe the acceptance criteria in the user story are structured in a really neat way, so you can almost copy those acceptance criteria into your code. They can become the title, the name of your acceptance test itself. This would be ideal. I have here a to-do app. It is inspired by the to-do MVC project, I guess, out there. It has 3 features. It can list to-dos, you can add to-dos, and you can remove to-dos. I have a few standard to-dos in there. If I were to remove one and I were to refresh the page, because it's a testing app, it resets the state. I'm not storing anything in the backend right now because this video would go way too long at testing all of that. You can add a to-do and it would add to the list, and you can remove it. It also supports not adding an empty to-do. Let's look at the code. The to-do app has a root component, the app, which renders a header, then the add to-do component, and then the to-do list component. Those are the 3 parts. It manages state via the use reducer hook, and it has acceptance tests inside the tests folder. The adding tests are there to add a to-do item by typing and pressing enter. I'm using the React testing library with just DOM, so I'm not using Cypress in here, which you might want to do if you're doing this on a larger scale. Also have a remove test. I'm injecting some state here because I also wanted to be able to inject an alternative state into app so I can mock this, but it's basically testing the same thing. Removing a specific to-do by clicking a button, seeing if the item that has been removed is not in the list anymore. So there's 2 components. The add to-do is basically a form that dispatches to the reducer. The payload is the value that was typed, and I have a to-do list, which is rendering in a ordered list some list items with a paragraph and a button to delete them if necessary, again dispatching to the injected reducer. And the reducer itself is fairly simple. It has a add and a remove action, and that's really it. There's some tests for that. Let's fold level 3. The reducer tests for add an item to the beginning of the list. It leaves the existing items as is. It doesn't add items with empty names, and it removes an item from the list. Those are the features that the app right now has. Let's assume my product owner has given me the following feature to work on. As a user, I want to mark to-do items as done without deleting them, so that I still have access to my completed to-do items in the future. Apparently there was some user testing and users were fairly frustrated that they would not have access to their completed items. They were forced to delete them. The acceptance criteria are: items marked as done are displayed visually distinct. Items marked as done are sorted below the items marked as to do, so there's a sorting difference. And newly created items are not marked as done by default. That makes sense. And the UX designer, which is also involved, has said items marked as done are displayed with a strike-through text style. See the Figma design that was made. Let's work on the first one. Let's create a new item. Let's call it status.test, because we are now dealing with different items in different statuses. Stati. Describe. We are marking as done. Mark as done. Let me just paste that thing in here. Items marked as done are displayed visually distinct. So whether we are actually going to test for visual differences is, of course, the question, because I don't think that's a good idea. Maybe we can find a accessibility property or something like that. So let's see how far we get with this implementation. We have a specific item. Let's make it item index If I have 4 items, this would be the third. I'm going to render app. I'm going to see if I can find the... So let's check the removing one actually. That's closer to find a specific button. Let's think about this a bit. How are we going to implement this? This needs to be async. I think it makes sense if for a very beginning situation we would just make this whole row click, and that we would indicate this with a hand cursor. If you tap on it, you deactivate it, and if you tap on it again, you activate it again. It's just a simple toggle. So we can figure out the state from a temporary property or a data, maybe a data test ID specifically. Let's see if we can come up with something. We are going to fire an event at some point. And this is not the button. This is the to-do item toggle. Query by test ID is probably a good ID for now. Click the thing, index. Let's see if it has been removed. Let's see if it has been checked. The expect becomes I'm going to expect this. Let's change this up a bit. Items. Item is. Items. We don't need this extra variable. And then we can expect item to have attribute or something like that, to have state or class, or we shall call this to-do item state. It's to do or done. So now it should be done. Items marked as done are displayed visually distinct. Let's go with this. See if the test fails. npm test. Indeed, it fails. Okay, now that we have this failing test, we can start the inner TDD loop. We can start to worry about how we would actually implement this on a unit level. If I think about this, I am definitely going to need a reducer state. We are going to need a toggle here. With some tests, of course, and in the to-do list we're going to have to render this state. So let's start with the to-do list. That's where we work from the outside in. So let's look at our test again. We are querying by test ID to do item toggle, so we'll need to implement this toggle. So let's use this as a value actually. To have attribute to the item state is done. So now that this item itself can have item that's done, otherwise to do. Now what will happen? My outer test fails, now I need to start working on my inner test. Given that I've just assumed a item.todo to be there, this state needs to be, of course, there. Let's go to the reducer, which doesn't have this state right now, it just has names. I need to add the states. If I look at my reducer, I have add, I have remove. I want to add a action toggle. So given a certain state and a certain action, I want another state back. That is what we are testing our reducer for. Let's test the from to do to done and then the from done to do. Toggles from to do to done. What did we name it? Did we say? We said done, and done is either true or false. Okay. So all the done is false. Action is toggle. There's no payload. New state is all of this. Actually, I do need a payload. I need the index to be toggled. And the new state equals. So index 1 is going to be toggled, so only this thing is going to be true, and it is not going to touch any other arguments in there. Does this test now fail? Yes, it does. My outer test is failing, my tests directory, which is my acceptance test. Now my inner test is failing as well, my reducer test. So let's implement it. Okay, toggle, return new state. We need to create a new state. It needs to be mutable. New state is state.slice, and we are going to update this one thing. New state index equals not new state index. We are of course getting a action payload, which is our index. So this should be our implementation. Let's see if it works. Our outer test is still failing. That is okay, we are not there yet. Our inner test seems to be okay, but we have made a mistake. By default they're all done false, and now I expect this to be done true. We are expecting an object done true name bar, but we are getting a false. That's true because we need to do this on a done property. There we go. Our inner test succeeds. Now our outer test is still failing. because we aren't done yet. Let's look at what's still going on here. The item.done should have, by default it is false, so if it is undefined it should also be false. Which means it still should then be to do. Expecting it to be done. And well, this is okay, we're of course not toggling anything, so we need to call toggle. The specific dispatch type that we are doing is toggle, and the moment we click on the P element, the paragraph, we're also calling toggle. And now it makes more sense. Let's see. And there we go, it succeeds. So now my outer test also succeeds. Great, let's go to the second acceptance criteria. Items marked as done are sorted below the items marked as to do. Let's take our test again and add a new acceptance test. Items marked as done. There we go. For this to work, we have to check the order of the items being returned. And I have already a test that I think does something similar. Do I? I do not, no. So I need to invent some more code. Item names map. Yeah, this could be some code that I could reuse maybe. For this, let's see. I am rendering an alternative state here to make my life a bit easier. I'm mocking my state. This needs to be an async function or the await will not work. I am rendering my app state. Instead of finding delete buttons, I will find the items. I want to toggle. No, I don't want to. Yeah, I want to toggle something. I want to click on that specific item. And now I want the item names. If I map them to plain names, because these of course are not names, they're elements. Items. Names. Expect names to equal an array, meaning to do 1, to do 2, and then we are not having to do 3, but we are having to do 4, and because to do 3 has been marked as done, it is sorted at the bottom. So this is a clash of names. I don't think we need this. Let's call it item elements. Get a item elements, and we map them to their names. So actually these are both elements and not text, so I can probably compare them directly already. I'm just going to say elements after. I can delete this and these become the elements before, or items before, or whatever. Item elements after. These are elements, but I can compare their contents directly. Let's see if it works. Or if it fails. It should fail, of course. So instead of strings, they are getting the wrong state for now. That is interesting. So it turns out I've made a mistake here. This is initial state, not alternative state. So let's see if that works now. Fails as I wanted to. Excellent. The order is wrong. The rest is fine. That is exactly how I want it to be, because right now I'm still at the state of the test has to fail and then I will start to implement the feature. Which is good. So if I go back to my tests, my items marked as done are sorted below the items marked as to do. I now need to implement the sorting feature. Where would I start implementing this feature? I think it makes sense to do this in the app. No, not the app, in the to-do list item. So in here I am mapping over the state. I probably want to sort the state first. So let's see if I want to add a util for this, or how shall we architect this? Sorted state, something like this. And then sort state, and this becomes something that we import. Import sort from util sort. Let's keep it simple. Now I need a util sort, and I need a sort test.js. Let's write the inner test first again. Import sort from sort. Describe sort. It sorts alphabetically, because that's probably a good idea anyway. No, it doesn't. I'm now changing the acceptance criteria, and this was never said. So new items are always added at the top. That is a feature on itself. Let's not do that. Now that I'm writing this doesn't make sense. It sorts by state. Done last. If I have a function in here that is going to be exported, sort equals, and then there's state in. Yeah, let's assume that. I'm starting with a certain state. I am getting a new state when I call sort, and I'm expecting that new state to equal something. So let's start with objects with names in there. Name A, B, C. I don't want it to touch it if none of this is done. Let's see what happens. Sorts by state right now. Excellent, undefined. The test fails. I can now move on. Of course, my ESLint started complaining in the meantime because I'm not using this code at all. That's fine. If I get a state, I'm expecting an array. I think the array built-in sort is stable, so let's assume that's the case. Array.prototype.sort. We're going to call this with the state object that we have. Compare A, B, and it will return a 0. I'll make it return a 0 if A dot done minus B dot done. Let's see what happens with the compare function. I could probably call this directly. I'm not sure why I'm over optimizing this. Let's see what happens. Okay, so these are my other tests. So my sort util is actually working now. So let's see if it leaves the other. So right now it leaves everything intact because it doesn't have a done yet. So this test is actually not okay. I should have added a done. False. Or maybe this test was correct, but its description was. Incorrect. So let's add the last thing to true, and here B was true. So then I want C to be there and B to be there. And it is succeeding. Let's add more cases because I'm not completely convinced yet. So I wanted to leave existing sorting So I'm going to take some state, then I'm going to expect the same state if I don't touch that state. If everything is false right now, I don't want it to be touched. Yes, this is fine. If everything is true, I also don't want it to be touched. Second case. False. True. Even if B is at the end of it. Yes, excellent. Maybe another one is it leaves other properties intact. Yeah, that's okay. We're using the default sort here. I trust this will be fine. So let's start using it. We have sort, we have a sorted state, and instead of state we now have sorted state. So we're not there yet. Let's see what's going on. We can probably inspect in the browser to figure out whether all our states are even being passed in the right way. So if I click on this first item, what will happen? If you mind this thing here, it does actually work. So my state is moving from to do to done and back. Also, if I go click other items, if I would open them, we would look at this word here. It moves to done and back. So this feature actually works. My sort order is not changing. So I guess my tests are not okay yet. Let's leave this there. We have a to-do list item that is using the sorted state. It is using the sort function from my util sort. And if I go in my util sort, I can see what's going on here. So let's see why this test case isn't covering that same case. We have a new state that needs to equal ACB, and this is ABC. So this is literally the same as that. We are not changing any of the state. This is literally the same as that, and this is the same as this last one. What I guess what we're not testing is that these objects do not always have the done thing in there. We are using defensive coding in our other tests as well. We probably want to have a test case for this, because I guess that's where the bug is. It's default to done false without done. If there's no done property, I still want the thing to work. If C has no done property, I still want it to default to false. Let's convert to Boolean very explicitly and see if that already solves our bug. There we go. And now we're back to the original feature. Items marked as done are displayed visually distinct. Now they don't have a done anymore. This seems to work now. If I move to my, click this, there we go. Suddenly the make example app, and if I click it again it doesn't work, but at least the sorting now seems fine. Okay, this is good news. This was the missing test case. But let's see what we broke. If I click this, then the to-do item state now of this item has moved to done. This is indeed what I expect. And the other ones are all in to do, done. Excellent. So probably my existing test case doesn't take this ordering into account. So if I go to my status test, if I mark something as to do, then item number 2 now has the state done. And this doesn't make sense anymore because the order has changed. So 2 doesn't mean what it used to mean anymore. We have an example of a brittle test. It is depending on a certain index and the item that is at index 2 has changed. We need to find all the items, grab the right one, and then check its status. So I think we have done a similar thing over here. We are querying for all the elements. And let's map over them. Column items here should really be consistent. That's a refactor part I'll do after. Elements and items. Items dot map, and let's see, we have an item here, an element here. This element is probably better. Let's see what we do here. We figure out whether this is the right one. If element.text contents equals the thing I want, so let's use state here as well for a full mock. Maybe we should move this up. What's going on here? Yes. If the element text content is, so we were changing number 3, is number 3, then we want to run expect on the element. I guess this should fix it. Let's see what happens. There we go. We fixed it. Let's see what happens over here. If I refresh this page, I click on the Make Example app, it is at the bottom. If I click it again, it is not changing the order back again, which is indeed what I expect, but it may not be what the user expects. But this could be an acceptance criteria that I want to check with my product owner, like, hey, do you expect it to fly back? Do you want this to be alphabetical by default to have more predictable behavior? I don't know what's going on here, but technically this is according to the specification if I don't invent new sorting rules. My items are there. Let's look at the other acceptance criteria. Newly created items are not marked as done by default. I think that's something we should also test for, but it's probably an easy one to test for. So when creating an item, newly created items. So let's add a to do. And after this thing is visible, we want this element not to be visible, but we want this element to have attribute, which is the other thing. Not removing status, we had a nice. So let's do this BEM style. If we have to do item done, then we can have a class with the modifying done, modifier done, and otherwise with the BEM modifier to do. So this is something we can put in our style sheet. To do item text decoration line through, which should then mean we have a line through states. There we go. We probably also want a cursor when we click it. Pointer also makes sense. There we go. Works like a charm. I think this user story is done. I hope this was a useful example. To summarize, TDD on a unit test level is the red-green-refactor loop, and on the acceptance test level is another loop around that. You first write your acceptance test, which may be an integration test, an API test, or even end-to-end test, and then you start going to one or more inner loops, where you do again the red-green-refactor loop. That's just how you look at it from a broader perspective. And user stories with good acceptance criteria will really help you in writing good acceptance tests, because you can literally just take these acceptance criteria into your tests and start using them. If you don't have these yet, start discussing with your product owner, start discussing with your team. You can probably make a change there. And my last tip is to practice with katas, code katas. I've talked about them before in my video on unit testing. If you're just getting started out with unit testing, test-driven development is a great way to learn it the right way. You probably also want to watch that video because it has a lot of the other basics out there. What is Jest? What is unit testing frameworks? What are they actually made up of? And code katas as well. They're probably a good way to actually get the hours of practice in that you need to get good at this. Same for TDD. And that's it. I hope you've enjoyed this. If you have any questions, if I've missed something, if I've made a mistake at something, please let me know in the comments. Thank you very much for watching.